Hey guys, welcome back. In this video, I'm going to show you how to find the antiderivative, which is also called integrals. Okay, so we have a power rule for integrals. And what the power rule says is that when you are trying to integrate x to the n, all we have to do is add 1 to the exponent and then divide by the exponent. Okay, so it's that simple. So let's take a look at this first example. Take the integral of x squared plus x to the third plus x to the fourth. With respect to x, all we have to do is take this exponent, add 1 to it, so that becomes a 3, and then divide by that exponent. Take this exponent, add 1, and divide. Take this exponent, add 1, and divide, and then we're going to add a c for a constant. The way that you could check your answer is, since these are antiderivatives, you could take the derivative of this and make sure that you get here. The reason why we have to put a plus c is because we know that if we took a derivative of a constant, the value would be 0. So with that being said, we don't know if the original function had a constant. So we're going to put a plus c. Okay, let's try another one. Let me change this color. What we're going to do is we're going to take this exponent. We're going to leave the 5 to the side. Okay, we're going to add 1 and then divide. We're going to leave this 3, the coefficient, to the side. We're going to add 1 and then divide. Now, one of the biggest mistakes that people make is they say the integral of 1 is 0. Well, the derivative of 1 is 0. The integral of 1 is 1x. Don't forget our plus c. You have to ask yourself, what gives me? So in this case, you say to yourself, what gives me 1? Well, if I took the derivative of 1x, I would get back 1. You must clean it up, obviously, and so we can cross off the 5s and the 3s. So you're left with x to the 5th plus x to the 3rd plus x plus c. Okay, so this is the antiderivative. Let's try a few more. In this problem here, I need to add 1 to the exponent. So what I need to do is take this term and rewrite it so that I have the exponent clearly stated. So what we have to do is, the way that we write the cube root of x squared is x to the 2/3 power. This person is the numerator, this person is the denominator. You can always think of denominators as people who dominate. We don't want them in our house, so we are going to put them outside. We will do the same here. This is x to the 4 over 5, and this is x to the 1/2. So we are going to integrate by adding 1 to the exponent, and then we're going to divide by the exponent. So what we're going to do here is we're going to add 1. Here's a really fast way of adding 1 to an exponent. 2 plus 3 is 5 over 3. You have to divide by 5/3. Instead of dividing by 5/3, you can multiply by 3/5. You need to add 1 to the exponent. So just say 4 plus 5 is 9 over 5. Instead of dividing by 9/5, you can multiply by 5 over 9. To add 1 to an exponent, you can actually just add the numerator and denominator together over the denominator. So divide by 3/2 means multiply by 2/3. And don't forget your plus c. Okay? When you take the integral, you're always asking yourself, who gives me? So who gives me secant squared? Tangent. The derivative of tangent angle is secant squared angle. Okay, so that's all you have to do. What about products? Well, we don't know how to integrate products. So the only way you can take the antiderivative is if you have them expressed in terms separated by pluses and minuses. We can't do products and we can't do quotients. So what we're going to do here is first rewrite this. X squared times 2x is 2x to the third. X squared plus x squared times a positive 1 is positive 1x squared. Positive 8x is 4 times 2x, and 4 times 1. Now, all you did was rewrite the problem. That doesn't mean that you took the integral, okay? So we need to make sure that we stay consistent with these long s's. We're going to add 1 and then divide by the exponent. We're going to add 1 and then divide. We're going to add 1 to the exponent and then divide. And who gives me 4? Not 0, 4x. I recommend that you first add 1 and divide, and then clean it up at the very end. 2 over 4 is a 2 on the bottom. 1 over 3, 4x squared, 4x plus c. If I'm going too fast, you can always pause or rewind, okay? So we can never ever integrate products. We can't integrate quotients. So what do? As long as there's a monomial in the denominator, you can separate each one by writing the expression as follows. Give the x to each piece, just like I did in green. Then you want to simplify because they're still quotients. X squared over x is x. 4x over x is 4. And then we still have this 1 over x. So what we're going to do is we are going to add 1 to the exponent and then divide. The integral of 4 is 4x. And the reason why I didn't bring x to the first up in the numerator as a negative 1 is because I know someone gives me 1 over x. Do you remember who gives me 1 over x? The natural log. The derivative of the natural log of x is 1 over x. Okay? So this is like the only quotient that you can have. Had it been 1 over x squared, let's see. Had it been 1 over x squared, 1 over x to the third, and so on, we would rewrite it just like this. And then we would integrate by adding 1 and dividing, by adding 1 and then dividing. And then you should clean this up to be negative 1 over x, negative 1/2 over x squared plus c. Okay? So I believe that's all I'm going to do for this video. So I hope that was helpful. Just remind yourselves that you cannot integrate products and quotients, and remind yourselves that you can you should have it in the form that's separated by pluses and minuses. We are going to be able to do products and quotients, but that's in our 2 videos from now, okay? I'm going to leave you with this. A lot of students think that the integral of pi is pi squared over 2. Pi is a number that's irrational, but it's approximately 3. If I said, what is the integral of 3? Wouldn't you say 3x? So what is the integral of pi with respect to x? Okay, so that's all for this video of basic integration. I hope it was helpful. Come back for the second fundamental theorem of calculus, followed by u substitution.